All right, let's talk a little bit about slope a little bit more. We're going to expand what we just talked about. Just look at a couple other different examples and different ways of getting the slope. So let's go ahead and talk about slope again as a rate of change. How is y changing as x changes? All right, now let's look at our graph first. Let's understand what's happening. It says it shows the average low temperatures in Anchorage, Alaska. So x is increasing by months. Now, if it's too difficult for you to think of those as months, then write numbers. January is the first month, February is the second, third, fourth, and so on. All right, then you don't have to worry about it being months instead of numbers. You can think about it in terms of numbers. All right, now our first question is asking us between which 2 months was the positive rate of change, the slope, the greatest. All right, now we haven't really talked about positive and negative slopes yet, but you can probably reason out that when x is increasing, if y is increasing, that's a positive slope. If y is decreasing, that's a negative slope. So everything from January to July, you can see that all of those y values increase. And so those are all a positive slope. Everything from July to December, all of those y values, the up and down, are decreasing. Therefore, those are a negative slope. So can you see where along here there's the greatest change from 1 month to the next? Well, hopefully you've identified this right here from March to April, because that's where it's the steepest. All right, so March to April, that would be the answer to A. Between which 2 months did the temperature decrease at the slowest rate? So now we're looking at the decreases. That's from July to December. So from July to December, it's going down. So when is it going down the least, at the slowest rate? All right, so let's consider from each of these, and we look, and where is it the least steep? Well, probably one of these two, but when I look at it, I say, you know what, this is going from 15 to 10, and this one's going from about 52 to 50. So I'm going to say from July to August is the lowest decrease. All right, so that's the slowest rate of decrease. All right, so July to August would be the answer to B. Letter C, use 2 terms to describe the rate of change from January to March. All right, well, the first term I would use is positive because it's a positive increase. And the second term that I would likely use is that it is increasing. And so increasing and positive generally tend to go together. They mean about the same thing. All right, so there's just looking at rate of change. Now, if we wanted to actually find a slope, we could do that. Let's do that for letter A. Let's find the slope, the rate of change for March to April. And so what we would do is we would just take those 2 points. Like I taught you in the last one, we can do y2 minus y1 over x2 minus x1. And that will give us the slope. So again, I'm doing part A here. I'm not going to do all of them, just this one. So I'm going to need to label these 2 points. Now, the one at April looks like maybe it's at 4, and then it's a little bit above 30. So I'm going to say 31. All right, and then this one right here in March, so that's 3, comma, and I'm going to again say that's probably a little more than this hash mark, which is 15. So I'm going to say 16. All right, so from here, I would go ahead and put it into my equation. I'm going to call this the second point and this the first point. So y2 is 31 minus the first point, which is 16. And then x2, which is the x value of the second point, that's 4, minus the x value of the first point, which is 3. So 31 minus 16 is 15 over 1. Now, of course, this is in degrees Fahrenheit, and this is 1 month. So that is the greatest rate of increase, is that it went up 15 degrees Fahrenheit in 1 month. All right, let's look at a couple of other examples just really quickly where we're looking at a rate of change. Okay, and we're going to try to answer these questions. So question number 1, let's go ahead and look at what it's giving us. These 3 graphs give us information. I'm sorry it says 6 to 8. This is obviously 1 through 3. Let's look at these graphs. These graphs are representing Donna, Paula, and Jeff as they're traveling. We want to use these graphs and talk about how this is affecting the rate and the slope. So let's look at the first one right here. The questions are, what is the rate, who's traveling the fastest, and what does the y-intercept mean? All right, well, let's start with the rate. So if we look at this graph right here, we need to find out what the rate of change is. Now remember, rate of change is the same thing as slope. Now you can do a rise over run. I'm going to prefer, because I want you to get used to this formula, doing the m equals y2 minus y1 over x2 minus x1. All right, so I'm going to choose 2 points that I know are right on the line. I'm not going to choose this one because I'm not quite sure if that's 7 or not. So I'm going to go up here till I see one that crosses again. So right here. All right, so I've got the point 0, 4, and I've also got the point 4, 16. And so I'm going to use those 2 points. I'm going to go y2, so I'm going to call this my second point, this my first point. So y2 minus y1 over x2 minus x1. And when I do that, I'm going to get 12 over 4, which is 3. Now, that's 3, but the 12 had units. The 12 up had units of miles. So miles on top, and then on the bottom would be time in hours. So the rate of change is 3 miles per hour. All right, so again, you could leave it in this form. You could leave it as 3 over 1. That's fine. Whatever is comfortable for you when you're dealing with the slope. All right, let's go ahead and look at Paula. Again, I'm going to try to choose a couple of points. So I've got this one, and it looks like it's going right through that point right there. It does look like they go through each of those. So we'll go ahead and use the easy ones. So we'll go 0, 24, and this one is 1, 20. All right, so we've got those 2 slopes. I'll use this as my second point, and this is my first one. So this is 2, this is 1. So I'm going to go 20 minus 24 over 1 minus 0. And when I do 20 minus 24, I'm going to get negative 4. 1 minus 0 is 1. So negative 4 over 1. Again, the units of the y's are in miles, and the 1 is in hours. Now, notice that the magnitude here is bigger, right? It's 4 per hour, whereas this one is 3 per hour. Now, what does the negative mean? Does that mean I'm going slower? No, the negative actually resembles the fact that you have a negative slope, which is decreasing. Remember in the last one we said that positive and increasing went together. Well, this is negative and decreasing. All right, let's do the last one. Let's pick a couple of points off. And this is 6, 16. And this is 1, 16. Now, from your experience, what's happening to Jeff? Remember, we did something like this in the motion lab. But what exactly is happening here to Jeff? Well, hopefully you said that Jeff is standing still because he's staying at the same position. All right, so let's go ahead and use this as my second point. So 16, y2 minus y1 over x2 minus x1. So there's x2, there's x1. If you need to label these, go ahead. x1, y1, x2, y2. And that may be helpful to you as you're trying to put these in as the slope, which is the rate of change. 16 minus 16 is 0. 6 minus 1 is 5. 0 divided by 5 is 0. So 0 miles per hour, which represents the fact that he's not moving. All right, so we've found the rate, which is 3 miles an hour, negative 4 miles an hour, and 0 miles an hour. Again, the negative is describing the negative slope, which is that the distance is decreasing. It's not that the rate is decreasing, it's that the distance is decreasing. Which person is traveling the fastest? Now, it's tempting to say that Dawn is traveling the fastest because hers is the largest number as far as positives and negatives. However, if we understand that the negative just means that the distance is decreasing, then we actually note that Paula is traveling at 4 miles an hour. She's just traveling in a different direction. So Paula is traveling the fastest because her rate of change is the greatest. All right, now the last one, what does the y-intercept in each graph represent? Well, what does this mean? 0, 4. We wrote it down, but what does that mean? Well, it means at time 0, when we started, her distance was 4. This means that Paula's starting distance was 24. this means that Jeff's starting distance was 16. And you got to get used to saying it in that format, the starting distance, not just saying when time is 0, because that's boring and too math-like. We want to say that he started at this place, because that's what that's trying to tell us. All right, well, I am done with introducing you to slope. Sorry the videos were a little longer than planned, but we're done.